In the deep ocean, death does not end. It transforms. When something massive dies in the open sea and sinks to the bottom, it becomes more than a corpse. It becomes an island, an oasis, a temporary world that can sustain entire ecosystems for decades. Scientists call these events whale falls, and for centuries we believed we understood what happened to them. Scavengers would arrive. Sharks, hagfish, crabs. They would consume the soft tissue over months, leaving behind a clean skeleton, a monument that could last a century or more on the cold, stable ocean floor. But in the late 1990s, researchers studying these sites began noticing something impossible. The skeletons were vanishing. February 2002, Monterey Canyon, California. A research team deploys a remotely operated vehicle to a gray whale skeleton resting nearly 3,000 meters below the surface. The whale died 4 months earlier. The soft tissue has been consumed. Only the massive bones remain. Except, they should weigh several tons. According to the vehicle's instruments, they weigh roughly half that. The team reviews the footage, brings the cameras closer, and that is when they see them. Pink, feathery, hundreds of them, erupting from the bones like some macabre bouquet, swaying gently in the deep current. They are not flowers, they are worms, living inside the skeleton, growing out of solid bone. The lead scientist examines the bone surface in detail. It is riddled with holes, tunnels branching through calcium like termite damage in wood. But this is bone, calcified, one of the hardest biological materials produced by vertebrates. And the worms have no mouth, no stomach, no eyes, no digestive system whatsoever. Just root-like structures, pale green tendrils burrowing deep into the bone, dissolving it with acid. The team searches the databases, consults colleagues. No one has ever documented anything like this before. In 2004, the discovery was announced. A new genus, Ossidax, from the Latin bone-devourer, zombie worms, and almost every aspect of their biology defies conventional understanding. The zombie worm lacks every organ one would expect a living creature to require for feeding. No mouth, no anus, no stomach, no digestive tract of any kind. So how does it consume an entire whale skeleton in a matter of months? The answer lies beneath the bone's surface. From the worm's body extend structures that resemble plant roots more than animal tissue. Pale green, branching, penetrating deep into the bone. These roots secrete a powerful acid, strong enough to dissolve bone faster than flame. The secretion breaches the bone's outer surface, then penetrates deeper, breaking down marrow, dissolving collagen, releasing lipids, chemically liquefying solid bone. But the worm cannot absorb these nutrients directly. It requires assistance. Living inside those root structures are billions of symbiotic bacteria. They digest the dissolved bone material and convert them into forms the worm can absorb directly through its skin. No mouth, no stomach, just acid, bacteria, and absorption. The zombie worm is essentially a living chemical processing plant. But that is not the strangest aspect of its existence. The large worms visible on whale bones, the ones with pink feathery plumes, are all female. 1 to 3 inches long, clearly visible, dominating the skeletal surface. For years, scientists searched for males. They examined hundreds of specimens. The males were nowhere to be found. Then, in closer examination of the females, researchers discovered them. Inside the females. Not beside them, not near them. Dwelling within the female's gelatinous tube. Microscopic, barely 1 millimeter in length. 50 to 100 of them inhabiting each female. They possess no roots, no plumes, no means of feeding independently. They exist for a single purpose, providing sperm. The male zombie worms are living reproductive cells. No autonomy, no movement beyond the female's tube, no independent existence. The entire male population of the species resides inside female flesh. It is among the most extreme examples of sexual dimorphism in the animal kingdom. But the story becomes stranger still. The larvae, when they hatch, have no predetermined sex. If a larva settles on bone, it develops into a female. If a larva settles on a female worm, it becomes male. The same organism, two entirely different destinies, determined solely by where chance causes it to land. Environmental sex determination, a biological caste system. Whale falls are extraordinarily rare events. Across the vast Pacific Ocean, a whale dies and sinks perhaps once every few kilometers of seafloor, sometimes far greater. For the zombie worm, this presents an evolutionary challenge. Their food source appears randomly across thousands of miles of abyssal plain. Finding a mate should be functionally impossible. The solution? Females carry their mates with them. When a female larva locates a whale skeleton and settles onto bone, she begins secreting chemical signals. Pheromones drifting through the current. Other larvae detect the signal, swarm toward it, land on the female's tube, transform into males, and migrate inside. Within weeks, a single female may house dozens of males, all ready to fertilize her eggs, and reproduction begins remarkably quickly. The female starts producing eggs just 6 weeks after settling on bone. Most deep-sea organisms require months or years to mature. The zombie worm achieves it in 40 days. Because whale falls do not last, other scavengers are coming. Bacteria are working. Time is limited. The worms must colonize, reproduce, and disperse before the resource is exhausted. Their larvae can survive at least 10 days drifting through the water without feeding, searching, waiting for chemical signals that might indicate the next whale fall, the next island of the dead. And when they find one, they colonize within hours. A whale skeleton resting on the deep ocean floor should persist for decades, perhaps a century. The bones are massive, dense, heavily mineralized. Bacteria alone would require 50 years or more to decompose one completely. Zombie worms reduce skeletons to fragments in months. Not years, not decades, months. Early researchers documented the process by marking whale fall sites and returning periodically. Vertebrae riddled with so many tunnels that they crumbled when touched. Entire ribs reduced to fragments. Mineral residue. The worms were dissolving bone faster than any natural decomposition process scientists had documented. Faster, remarkably, than combustion. And they accomplished this feat on the largest animals Earth has ever produced. Blue whales, fin whales, humpbacks, basking sharks. When something massive dies in the deep ocean and sinks, the zombie worms find it. They erupt from the bones within days. Thousands of them, their pink, feathery plumes swaying above the skeleton like some grotesque garden growing from death. But their reach extends even further back in time than whales. In 2011, paleontologists examining fossilized bones of ancient marine reptiles noticed peculiar damage. Plesiosaur bones, sea turtle shells, giant fish from the Cretaceous period, tiny holes. Intricate tunnel networks riddling the fossilized remains. The patterns were identical to damage left by modern zombie worms. Further analysis confirmed it. These worms are at least 100 million years old. They did not evolve alongside whales. They evolved during the age of dinosaurs, when massive marine reptiles dominated the oceans. Mosasaurs, plesiosaurs, giant sea turtles. When these animals died and sank, zombie worms fed on their bones. For 65 million years after the Great Extinction, they persisted. Then whales evolved, large, abundant, rich in oils and lipids. The worms found an ideal food source and diversified. Today, scientists have identified 26 distinct species of Osidax, each specialized for different bone compositions, different depths, different temperatures. They have colonized every ocean on Earth. There is another critical function: carbon cycling. When a whale dies, its body contains tons of carbon. If that carbon simply rested on the ocean floor for centuries, it would remain sequestered. Zombie worms release it, break it down, convert it into forms that bacteria and other organisms can process. Some scientists believe zombie worms have been influencing ocean chemistry for millions of years. They are not merely scavengers. They are fundamental components of how the deep ocean functions. But recently, something went wrong. 2012, Barkley Canyon off the coast of British Columbia. Researchers placed humpback whale bones on the ocean floor nearly 1,000 meters below the surface. High-resolution cameras were installed. Oceanographic sensors deployed. This is whale migration territory. Whale falls occur here regularly. The worms should have appeared within days. 10 years of continuous footage. Not a single zombie worm colonized those bones. The skeleton rested untouched. Bacteria worked slowly. Other organisms arrived and departed. But Osidax, the creature that should dominate whale falls, never came. Scientists checked other nearby sites. The results were consistent. The zombie worms are missing, and the reason is deeply troubling. Barkley Canyon lies within a naturally occurring oxygen minimum zone. These zones have existed for thousands of years, but they are expanding. Climate change is warming surface waters, reducing oxygen solubility. Slowing ocean currents diminishes oxygen circulation. The dead zones are growing larger, deeper, more extensive, and zombie worms cannot colonize bones within these expanding zones. Whale falls function as stepping stones. Zombie worm larvae drift from one skeleton to the next, sometimes across hundreds of kilometers. If those islands sink into oxygen-depleted water, the connections break. Populations become isolated, unable to reach one another. Scientists are documenting potential species loss in real time. The worm that consumed dinosaurs, that shaped ocean ecosystems for 100 million years. Vanishing. Nothing about zombie worms should be possible. They consume bone without mouths, digest nutrients without stomachs, navigate their world without eyes. Males exist as microscopic prisoners inside females. Larvae determine their sex based solely on where they settle. They dissolve bone with acid more efficiently than fire. For 100 million years, they have served as the ocean's cremation system, breaking down the largest animals that ever lived, releasing carbon locked in bone, creating ecosystems from death. They appeared on the corpses of marine reptiles in the age of dinosaurs. They adapted when whales evolved and filled the seas. They are fundamental to nutrient cycling in the deep ocean, and we are watching them disappear. Not from overfishing, not from direct harvest, from changes we are making to the basic chemistry of the ocean itself, heating the water, expanding dead zones, cutting the connections between the islands they require. Somewhere, right now, on a whale skeleton a mile below the surface, pink feathery plumes wave slowly in the current. Pale green roots burrow deeper into calcium. Acid dissolves bone marrow. Microscopic males wait inside female tubes. Larvae drift through darkness, searching for chemical signals that might indicate the next island. Because nothing about the worm that eats bone is normal. And losing them would unravel ecosystems we are only beginning to understand. Something evolution required 100 million years to perfect. Gone.